What's up, guys? We're now day 10 of the Leetcode challenge. Cool, we got min stack. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. We got push, which push element X onto stack. Pop removes the element on top of the stack. Top, get the top element, and get min, which retrieves the minimum element in the stack. Doesn't seem too bad. Look, we gotta make all of our methods for our data structure, which is convenient because yesterday's challenge, my last video, we had dealt with the stack data structures. So this little hint here indicates consider each node in the stack having a minimum value. So that we should probably have two values with having a value of the current minimum element. So this is what I'm thinking we're going to do. Good old MS Paint for visual representation. So we got our stack. So how the stack works, when we put an element into the stack, it's going to stay there. Then when we put another element into the stack, we can't access this bottom element because this is on top of it. So if we remove this element here, then we can get to the stack. If we were to put another element into the stack, then we can't access this element unless we remove this element. That's how stacks work. So we'll put in our first element. It's going to be -2. Yeah, and it's going to hold two values. That's what our hint indicated. This will be the actual value object in the stack, and then we'll have our current minimum value. So it will be itself, because this is the only item in the stack. Then we got our next value. Let's say it's 0. So 0 is obviously greater than -2, so we're going to keep our current minimum to be -2. So if we add an additional item to our stack, say it's -3, that's even lower. Then our current minimum is going to be -3. So then, if we were to remove this item in the stack, our current minimum would be -2, because we removed -3 in the stack. That's how we're going to go about tackling the problem. So, just like last challenge, we'll go ahead and use Java's embedded stack in its API. So, why recreate the wheel if Java already has it, right? So, we'll initialize stack here, and then we initialize this because up here, because the values and attributes of the class need to go at the top here, so they can always be referenced. So here we got stack equals new stack. This adds element to the top of the stack. So for now, pop, we got a stack dot pop. Easy as that, right? Well, not quite. We know we're going to have to do the 0th index because we're going to have two indexes in each element of the stack. We'll have our 0th element and our first element. Well, this is void, so we actually don't really have to return anything at all. It returns the top element, so this will do 0th. For our get min method here, we can't keep popping the stack, because then we'd be manipulating the data structure. It's not what we want. We want to just get the min value. So the min value is going to be on top, second index of the array. So here we would just simply go stack.peak, because we're not getting rid of that element, we're just returning the one element in that stack. That should be how it goes. So now we need to keep up with minimum element in our push method. Remember that we need to keep that current minimum to the second element in the array. Or we'll do if stack dot is empty, then we're going to push. We're going to stack dot push. We need to initialize our array first. So integer array equals new int of size 2. And stack dot push x. No, right here. Not 2. We need to do x like that. And then we'll have array like so. If the stack is empty, is true, then we're going to make this array. And inside of the array, we're going to have the minimum value be itself. And then else, we're going to have another conditional statement to check if the next element coming in is less than the current minimum of the previous element, then we're going to change the element that's coming in second index to the element of itself. That sounds a little confusing. Not as confusing. It's just like if if we drop in -3, we want to check this -2 right here. And since -3 is less than -2, we're going to drop in -3, like so. Integer current min to equal stack dot peak, which we're looking at the top, but the second index of peak. And then we would do if x is less than current min, and current min equals x. Yeah, but then here we would initialize our new array here. Int array equals x, and then current min. And then we would do stack dot push array. That looks about right. This whole conditional right here, if stack is empty, then we're going to make an array of the elements of themselves. And then we're going to push that array into the stack. That would be the first element in the stack. So if array is empty, add element to stack and min to itself. But if x is less than current minimum, say we drop the -3, then current minimum is going to be that -3. But else, if this conditional doesn't go through, then current min is going to continue to be that previous current minimum in the stack. Cool, and then we push this array, and I think that does. Well, I think that's that. Let's go ahead and run. We got a little compile error. Let's see, I did something wrong here. I need to put a return statement. Yeah. Oh, yeah, we forgot to put that right there. Of course. Let's try that again. Finish, here we go. Yeah, so let's go ahead and submit. Let's see what we got. No errors, and accept it. And that's that. That is an O of n. We're not going through stack more than we have to. We're keeping track of that. Thanks to this hint right here. Oh, this helped out a lot. Each node in the stack having a minimum value. Yeah, like I said, that helped a lot. I would have had a lot of trouble if I didn't have that. But yeah, that concludes that. If you guys would have done it any differently, please leave something. Help us all out. Yeah, stay tuned for next time. Day 11, I believe.